Welcome, geometry students, to week 3 of distance learning. Last week we finished up the chapter on area, two-dimensional area. This week we are jumping into the chapter on volume. To start us off here, we're going to be looking at the surface area of a three-dimensional object. The two sections that we're going to be going through today is the section on surface area of prisms and cylinders, and then surface area of pyramids and cones. What you're going to see up here is I have all of the formulas that you need to tackle these questions this week. Okay, so all of these formulas you're going to need to reference to tackle these questions. So for prisms, the surface area of a prism is the lateral area plus 2 times the area of the base. And then the lateral area, the area around the three-dimensional prism, is the perimeter of the base times the height. The lateral area plus 2 times the area of the base. The lateral area, okay, is the perimeter times the height. For cylinders, it's the same thing. Surface area is the lateral area plus 2 times the area of the base. The base in a cylinder is always a circle. The lateral area of a cylinder is perimeter times height. So if you think about the perimeter of the circle, that would also be known as the circumference. So that's why you see 2 pi r in the formula. It's the circumference, or the perimeter of that circle, times the height. And then the last two, pyramids and cones. The surface area of a pyramid is the lateral area plus the area of the base. The lateral area of a pyramid, if you think about pyramid coming together, every side of that pyramid, excluding the base of course, but every side of the pyramid is a triangle. Okay, so every side is a triangle. So when you think about the lateral area here, it is 1/2 the perimeter of the base times the slant height. Which is the line that goes down to the middle of that triangle. The cone. The surface area of a cone is the lateral area plus the base. The lateral area is pi r L. So you may be thinking, why isn't it 2 pi r L? And the reason why is because you have the same formula like in the pyramids, the 1/2 perimeter. So 1/2 of 2 pi r is simply pi r. So the lateral area is simply pi r L. So I'm going to give you a chance to write all of these down, and while you're writing that down, I'm going to go ahead and start putting up some examples. We're going to work through quite a few examples here. We're going to be utilizing prisms, cylinders, pyramids, and cones. I'm going to do the prisms and cylinders in red, and then I'm going to be putting the pyramids and cones in green. So example 1 and example 2. Example 1, we're going to be looking at a prism. We're going to go through and find the lateral area, and then we're going to go through and we're going to find the surface area. For the cylinder, we're going to do the same thing. We're going to go through and find the lateral area first, and then go through and find the surface area. As you see with the assignment this week, you're going to be going through, and questions may ask you for finding both. Questions may ask you for just finding the lateral area. And so I want to go ahead and show you how it works no matter what kind of questions you're asked. As you can tell, example 1 takes up a little bit of space. So I went ahead and cleared off the board so that we could tackle example 1. For this example, what you're going to do is you're going to need to find the lateral area and the surface area of this triangular prism. The first thing that we need to do is find the lateral area. So our lateral area is equal to the perimeter times the height. As you can tell, we don't have the entire perimeter of that triangle. So what we're going to have to do first is go in and get that third side of our triangle. We can do this by utilizing one of the most popular theorems in all of math, Pythagorean theorem. (12 squared plus 12 squared equals c squared). 12 squared plus 12 squared is 288. And then we'll square root both sides. So 17 meters is our third side. So for the lateral area, the perimeter times the height. The perimeter is 12 plus 17 times the height of 8. Which, when you plug it in, is simply 328 meters squared. Now we're ready to look at the surface area. The surface area is the lateral area plus 2 times the area of the base. We already have the lateral area of 328, so we can go ahead and plug that in, plus 2 times the area of this triangle. Area of a triangle is 1/2 base times height, so 1/2 12 times 12. So the surface area is 472 meters squared. Now that we finished the first example with the triangular prism, let's go ahead and move on to example 2. I'm going to go ahead and put up the formulas back up on the board with example 2. The cylinder has a diameter of 6 meters and then a height of 4.8 meters. So here we go. We're going to use these cylinder formulas and we're going to try to find the lateral area and the surface area. First thing is finding the lateral area. The lateral area is 2 pi r times h. We were given the diameter, so if we think back to our circle unit, which was 2 units ago, and the very first lesson was dealing with diameters and radius, and so 6 is the diameter, so to get the radius, we just simply divide it by 2, so 2 pi 3 and then the height is 4.8. So if you plug that in, you get 90.4 meters squared. Now keep in mind, as you're tackling these problems, depending on how you put in pi will depend upon how much your answer varies. So if you put in 3.14 or you shorten pi to 2 digits or truncate pi at 2 digits, you are going to have a different answer than someone who uses the pi button. So what I did here was I used 3.14. So if you plugged in the pi button for pi, you're going to have a little bit of a different answer here. So I want you to see how that works. Your answer, if you use the pi button, is technically more precise than this answer. This answer is more of an approximation. For this assignment, I will accept either way. Now the second step, surface area. The surface area of a cylinder is the lateral area plus 2 times the area of the base. So 90.4 plus 2 times the area of that circle. And if you remember back to that circle unit in the very first lesson, we talked about area of circles, which pi r squared was a formula many of you were able to reference without going to your textbook. So in here, the area of the circle, pi r squared. So in this case, pi 3 squared. So in this case, your surface area is 147 meters squared. That takes us through the prisms and cylinder examples. For the assignment with prisms and cylinders, you're going to be looking at finding either surface area or lateral area of either of those types of three-dimensional figures. Now we're going to switch gears and look at our pyramids and cones. So example number 3, we're going to be looking at a square pyramid. Okay, so you can see here a square pyramid. What they've given to us is the straight up and down the altitude of the pyramid, and they gave us the slant height of the pyramid. What we're going to be doing is the same thing from example 1 and example 2. We're going to go in and we're going to find the lateral area and the surface area of this square pyramid. When you look at the square pyramid here, you're going to notice you have a lot of information dealing with the inside or the sides of the pyramid, but you don't have any information dealing with the base of the pyramid, which is extremely important when utilizing either one of these two formulas. So hopefully what you've seen right here is you kind of can see that triangle that goes down the side of the pyramid, the middle of the pyramid, and part of the base. Okay, that's going to be important because we don't have any information about the base. What we're going to have to do is we're going to have to use Pythagorean theorem to solve for that length at the bottom, which will then give us enough information to start labeling pieces of the base. So using Pythagorean theorem, we'll just say a squared, because it's in the formula, a squared plus 9 squared equals 11 squared. A squared plus 81 equals 121, and we'll solve for a. So subtract your 81 over, which gives you 40, and then we'll square root both sides. Rounded, 6.3 inches. Now, that's extremely important because what that gives us is that gives us this half of the length. So that means that we can label all of our bases by simply doubling that length. So 12.6 inches is every length of that base. Now that we have that length, we're going to go ahead and plug our information into our two formulas to get the lateral area and the surface area. So for the lateral area, it is 1/2 the perimeter times our slant height. Our slant height in this case is 11. The perimeter of this square pyramid is 12.6 times 4, or 50.4. Which, if you plug it straight into your calculator, you're going to get 277.2 inches squared. That is the answer for the lateral area. Now we're going to utilize that information and find the surface area. There again, same thing at the top. Surface area is the lateral area plus the area of your base. So the lateral area, 277.2 from what we just found, and then add in the area of the base. The area of the square is length, 12.6, times width, 12.6. So 12.6 times 12.6. So the surface area is 436 inches squared. That concludes example number 3. We're going to go ahead and look at example number 4. Example number 4 is going to be the toughest example that we look at. It's dealing with regular figures like we had at the beginning of this distance learning, the very first lesson of distance learning. And so we're going to be utilizing 1/2 AP when we're doing this, so that'll probably be the toughest example. So let's go ahead and get started with example number 4. So for example 4, we're going to be looking at a pentagonal pyramid. This is utilizing our regular figures. So when you think about a regular pentagonal pyramid here, we are going to start finding the apothem here. We're going to have to start finding the apothem. And the reason why is so that we can not only do the area of the base in our surface area piece, but also it will help us find our slant height and make that triangle like we did in the last problem. So if you think about the base of the shape, it has a length of 4 on every side. And then our apothem is going to be there in the center. And so what we're going to do is we're going to create this idea of a triangle, and then we're going to go through and use our sine, cosine, and tangent. So I want you to follow along here. What we have is we've just looked at the base. The base has a length of 4 on each side, and then the apothem is, of course, a line from the center to the middle of a side. So now we're going to take this slice and we're going to pull it out. So we pulled the triangle out that is right there. So since we pulled that triangle out, we only need, because it's right there, we only need half of that length. So 2 will go right here, and the apothem, of course, is that line going up and down. Next, we are going to figure out what that angle is so that we can go through and get the apothem. So to get what that angle is, we take 360 divided by the number of sides. Is 72. Okay, 72 is basically 2 of those triangles put together. So for this angle, you're only going to use half, or 36 degrees. I know it looks kind of messy, so I'm going to go ahead and kind of clean it up a little bit, make it nice and neat. (36), 2, and A. So since we have the angle of 36, we have 2 is the opposite side, and the apothem is the adjacent side. We're going to set up tangent of 36 equals 2 over A. To solve this for a and get our apothem, you're going to multiply a to the other side, so a tan 36 equals 2, and then divide by the tangent. So rounded, a is 2.8 meters. That's a lot of work just to get the apothem, but rest assured, now that we have the apothem, we can go through and get most and all of these answers fairly quickly after that. That's going to be the most difficult part of this example. So now the apothem is 2.8 meters, and we have a triangle here. So now that we found the apothem, we're able to go in and get our slant height. So simply use your Pythagorean theorem, 7 squared plus 2.8 squared equals L squared. So 56.8 equals L squared, and then square root both sides. So 7.5 meters equals your slant height. Now we have everything we need to finally plug it into the surface area and the lateral area. Okay, so the lateral area is 1/2 the perimeter times the slant height. The perimeter of this shape is 4, 4, 4, 4, and 4, or 20. So 1/2 times 20 times 7.5 is 75 meters squared. And now the surface area. So the surface area is the lateral area, or 75, plus, and then you have the area of the base, which is 1/2 AP. So 1/2 A times the perimeter of 20 that we just found in the last part. So 1/2 2.8 times 20. One half 2.8 times 20 is 28, and then add 75 to that, and you get 103 meters squared. Now that we finished this example, this will be by far the hardest problems that you face in these assignments is going to be regular figures. So looking at your regular prisms and regular pyramids. If any of the problems contain regular figures or regular shapes like regular prisms or regular pyramids, then you will have to go in most cases, and find that A, which means it may take a little bit to find. Once you found it, that's the hardest part of the problem. Example 5, a cone. What you see here is a cone where they gave you the radius of 7, and then the altitude of the cone straight down the middle is 8. They didn't give you one of the important pieces of information when dealing with a cone. With a cone, the two big pieces of information that you need to do both of these formulas, and you only need two pieces, and that's the radius and the slant height. They gave you the radius, they didn't give you the slant height, so you're going to have to find it. Hopefully, what you see already is something we've utilized in most of our examples. A triangle and Pythagorean theorem. For the Pythagorean theorem, 7 squared plus 8 squared equals your slant height squared. Slant height of 10.6 meters. Now we can utilize both of our formulas and solve. pi RL, pi times 7 times 10.6, which is 233 meters squared. Then the surface area is 233, or the lateral area, plus the area of the base. The area of the base is pi r squared, so pi 7 squared. So when you plug it in, you get 386.9 meters squared for the surface area. That finishes up this question, and that finishes up this lesson on surface area. Now you'll see posted below the assignment that you're going to have for this week. If you have any questions, like always, feel free to post, email, reply, and I'll be glad to answer any of the questions that you have, and I look forward to seeing you guys soon. So have a great week.